today we're going to cover Chapter 7, Section 2. Today we're going to be covering properties of parallelograms. So the first thing we're going to do is define what a parallelogram is. And a parallelogram is a quadrilateral with two pairs of parallel sides. When you want to name a parallelogram, you either need to write out the word parallelogram in front of the four vertices, so the four capital letters, or the shortcut will be to draw a picture of a parallelogram in front of the four vertices. Now, the way that you name a parallelogram, it doesn't have to be in alphabetical order like it's listed here. You can choose any starting point and then just make sure you go in order around the sides, either clockwise or counterclockwise. So for example, I could have started over here with angle C or vertex C, and I could also have named this parallelogram, and then if I wanted to go backwards, I could also name them in order of C, B, A, D. I can't jump across and name it C, A, and then BD. I got to go in order. Or if you wanted to go the clockwise order, it could have been C, D, A, B. But I can't jump diagonally. So by definition, this side here, AB, is going to be parallel, and notice the arrows here, to CD, which is here. And then BC has the double arrow indicating it's parallel to the AD or the DA. Again, the order doesn't matter. So by definition, it's going to be a quadrilateral with two pairs of parallel sides. This is the definition. Next, we're going to learn four different theorems, which are really just going to be properties or characteristics of a parallelogram. So our first theorem is called the parallelogram opposite sides theorem. And what this theorem states is that if a quadrilateral is a parallelogram, then its opposite sides are congruent. So in the picture, you can tell it's a parallelogram because it's got the parallel sides. But in addition to the sides being parallel, this side over here, AB, is going to be congruent to CD, and BC is going to be congruent to AD. And the reason why I know this is by using the parallelogram opposite sides theorem. The second theorem that's here is called the parallelogram opposite angles theorem. And this one states that if a quadrilateral is a parallelogram, then its opposite angles are congruent. So they've color-coded it here, so you can see that angle D is in blue, and so is B. So angle B and angle D are congruent, and angle C and angle A are congruent. So again, if you didn't have colors, you could add in congruency marks. So you could have shown that A and C have the same mark, and then B and D. So opposite angles are congruent in a parallelogram. So the next theorem is called the parallelogram consecutive angles theorem. If you recall back to that prior chapter where we learned about parallel lines and transversals, this is where we learned about consecutive angles. They were also called same side interior angles. So this is just another name for it. So be aware of both names in case you see it on an SAT. So what this theorem states is that if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So consecutive, just like consecutive integers are numbers in order. So here the consecutive angles are angles that are side by side. So in this picture, you can see because we have two sets of parallel lines, notice I've got BC, which is parallel to AD, and then if I drew in a transversal here, and make AB the transversal, then angle A and B are going to be same side interior or consecutive interior, which makes them supplement. So that's why under the conclusion, they're showing that angle A plus angle B equals 180. Now, if I use those same parallel lines and then also use CD as a transversal, angles C and D are also supplements. Now, if I switched it up and now used AB parallel to CD, then I could also show that BC would be my transversal, which would then make B and C supplements. Or if I used AB and CD as the parallel, and again, AD as a transversal, then A and D are also supplements. So as you go around, the two that are on top of each other are supplements. And then the top two angles and the bottom two are supplements. So we have 4 pairs of supplementary angles here. They're the consecutive angles. The second theorem on this slide is the diagonals theorem, the parallelogram diagonals theorem. And this just states that if a quadrilateral is a parallelogram, then the diagonals bisect each other. So here in the picture, BD is a diagonal, and that tells me that since the diagonals are bisected, BZ is going to be congruent to DZ. So this piece is congruent here, and that AZ would be congruent to CZ. Now in the homework, they're going to give you a question like this, and they're going to say, what would be the coordinates for point Z? Well, point Z, if you think about it, since these two diagonals bisect each other, point Z is the midpoint of the two diagonals. So when you're doing the homework tonight, if it ever asks you to find the coordinates where the two diagonals intersect, all you need to do is find the midpoint of one of the diagonals. It's going to give you the same answer no matter which diagonal you choose. Now tomorrow, we're going to take these 4 theorems and we're going to learn converses for them. And we're going to switch it around, and this is where we'll be able to prove that a quadrilateral is a parallelogram. But for today, they're telling us that we have a parallelogram, and these are the theorems that apply to them, which are also really the properties of a parallelogram. Okay, now, in order to answer this, what you need to have been given is that ABCD, the parallelogram down there at the bottom, is a parallelogram. If they did not give us the fact that that was a parallelogram, I couldn't find any parallel lines in this picture. I can't assume anything. But because I'm going to tell you that ABCD is a parallelogram, I can now answer the 3 questions. So for the first question, it's asking me to name all the pairs of parallel sides. So by definition, I know that a parallelogram has 2 pairs of parallel sides. So I know that BC is going to be parallel to AD. That's my first pair. And that side AB is also parallel to CD. And again, the order of the letters doesn't matter here. Now, in this same picture, I'm going to go ahead and jump down and I'm going to answer number 3 as well. Because number 2 is going to be really intense. Because we actually have 8 different angle pairs that are in this picture. So I'm going to go ahead and do all of the congruent sides first. So remember, by using my parallelogram opposite sides theorem, I can state that side AB is congruent to side DC or CD. It doesn't matter. I can also state that side BC is congruent to side AD. So I can add in congruency marks. So remember, those purple arrows only indicated that they were parallel. The congruency marks show that they're the same. Now the other pair of congruent segments here, I'm going to be using my parallelogram diagonals theorem. And remember, that one stated that the diagonals bisect each other. So that tells me that BE is going to be congruent to ED. And that segment AE is going to be congruent to EC. So these are all my congruent segments in this picture. I use the parallelogram opposite sides theorem, and then I also use the parallelogram diagonal theorem. Now, to answer part 2, I'm going to just name part of the angles that are congruent in this original picture, and then I'm going to redraw the picture because there's going to be way too many markings in the picture. So my first set of congruent angles, I'm going to be using the parallelogram opposite angles theorem. And this is only going to give me 2 pairs. So I'm going to go ahead and label these in pink. So I know that this angle up here, and I can't just name it with B, I'm going to have to name it with 3 letters. But if the diagonals weren't in there, it would be angle B congruent to angle D. But I'm going to use 3 letters. So I can say that it's angle ABC is congruent to angle ADC. These are the opposite angles in the picture. Then I have another pair, A and C here, but again, I'm going to use 3 letters. So angle BAD is congruent to angle BCD. So I'm going to come over here and draw the same parallelogram again. You can keep using the same one if you wish. So B, C, D, A. I'm going to draw in the diagonals and point E here. Okay, so now I'm still answering number 2. So I've already done using the theorem we just learned. My next one that I'm going to identify are the vertical angles in the picture. So I've got 2 pairs of vertical angles. I've got a pair right here surrounding the E, and then another pair on this side. And again, I need to name it with 3 letters. So for the first one, angle BEC, the top and the bottom, and angle AED. And then the 2 on the side, AEB is congruent to angle DEC. These are the vertical angles in the picture. Now remember, we have parallel sides here. So now the next 4 congruent angles that I can find in this picture are going to be alternate interior angles. So what I'm going to do is I'm going to first use the top and the bottom as my parallels. And then I'm going to be using BD as a transversal, which has now created angle, this one here, congruent to this one. So angle CBD is congruent to angle ADB. These are alternate interior. Now I'm going to still use the same purple parallels, but now I'm going to use AC as a transversal. So now my transversal will be AC. Let me get a different color here. So this is my transversal now, which now makes this angle up here congruent to this one down here. So now I have angle DAC congruent to angle BCA. Now I'm going to use the parallel lines of AB and CD. So now I also have parallel lines going this way, up and down this way. And now I'm going to use, again, my transversal, which is the diagonal. So I could use this diagonal, AC, which then now forms this angle, 1, 2, 3, 4, 5, along with this one, 1, 2, 3, 4, 5. So now I can name this one as angle BAC is congruent to DCA. And then I'm going to use the other transversal, going with BD this way. So now the black and the green together is going to make this angle right here congruent to this angle right here. So angle ABD is congruent to angle CDB. So I actually have 8 angle pairs in this picture that I can find are congruent once you're just given that it's a parallelogram. So not only are we bringing back our parallel lines and our transversals, notice we've also created 4 triangles here. So we're also going to be bringing back our congruent triangle shortcuts in order to find some missing congruent parts and things like that when we're writing our proofs. Example 2. They're telling us that RSTU is a parallelogram. Now notice picture C down here doesn't have the letters, so I'm going to go ahead and add in R, S, T, and U. Also notice picture A was missing the variable A. So let's put an A down here on UT. So now to find the value of these variables, I'm going to use all of the properties that I just learned. So for the first one, since this is a parallelogram, and I know in a parallelogram, I know that opposite sides are congruent. So if RS is 6, so is UT. So A is 6. That's my first variable. And then B, same thing, opposite sides are congruent. So if that side over there is 9, then B is 9. And then for X and Y, I'm going to be using my opposite angles theorem. So since U is 80, then I know angle X is going to be 80 degrees. And now to find Y, I know that U and R are supplements. So if it asks you to write something algebraically, you could do 80 plus Y equals 180, subtract 80, and Y equals 100. If it doesn't ask for something algebraic, you can have just done 180 minus 80 and gotten 100. going to be using the same properties or the same theorems to answer part B. So for part B, again, I'm going to go ahead and A, B, X, and Y. So A, just like the other example, opposite sides are congruent. So A equals 12. Now B is part of that diagonal, and I know by the parallelogram diagonal theorem that diagonals are bisected. So if this one's 9, then B is 9. And to find, now X, this is what they're referring to where the arrow's pointing. They want you to find the measure of that whole angle there. So for X, again, I know that U and R together, those are supplements. So to find X, I can do X plus 35 plus 45 and set it equal to 180. 35 plus 45 is 80. Subtract 80 from both sides, and X equals 100. So X equals 100 degrees. And now to find Y, Y is going to be alternate interior to the 45. So Y equals 45. Now for figure C, it doesn't have A and B. It only has X and Y. So again, I'm going to use my opposite parallelogram opposite sides theorem. So I know that 8 and 4x are congruent, as well as 3y plus 4 is going to be congruent or equal to the 13. So my two equations to solve will be 4x equals 8 and 3y plus 4 equals 13. I can divide both sides by 4. X equals 2. And then for the y, subtract 4 and divide by 3. And y equals 3. So the next one, they want us to find the perimeter of parallelogram PINE. Notice a picture is not given, so I'm going to go ahead and draw a parallelogram. It doesn't matter where you put the letters, just pick a starting point and then go around the sides. So notice they told me that PI was 12, IN was 8, and I know that in a parallelogram, opposite sides are congruent. So if IN is 8, then PE will be 8. And if PI is 12, then EN will be 12. So now that I've filled in all of my sides, now I can go back and find the perimeter, which just means to add up all the sides. So I can add 8, 8, 12, and 12. Doesn't matter however you want to order them. And this will give me 40. So the perimeter, because there were no units on it, you could just say it's 40 units. All right, so we're going to be writing a 2-column proof. So again, statements on the left, reasons on the right. And they're giving us that ABCD is a parallelogram, and so is GDEF. So I need to state that given. So ABCD and GDEF are parallelograms, and this was my given. What they want me to try to show is that angle B is congruent to angle F. Now, since I have two parallelograms here, the first thing I'm going to do, because I'm trying to show some angles are congruent, that's going to be the theorem I'm going to use. I can state that this angle B here is going to be congruent to this angle right here. Then I can also say that this angle that's in this parallelogram is congruent to this. So I'm going to go ahead and state that. So number 2, I'm going to state, and I need to use 3 letters for the one in the middle. I can call angle B, but the other one across from it needs to be named with 3 letters because there's 2 angle D's there. So I can call it CDA, and then the other side is angle F with angle EDG. And the reason why I can state these 2 sets of angles are congruent by using the parallelogram opposite angles theorem. Now, if you forget the name, then you need to restate the theorem. And what this theorem states is that if a quadrilateral is a parallelogram, then its opposite angles are congruent.
That's only if you forget
That's only if you forget the name. Now, the next thing I'm going to show is that these 2 angles here surrounding the D, these are vertical angles. So my next statement is going to show that they're congruent to each other. So I can state that angle CDA is congruent to EDG, and this is the vertical angles congruence theorem. And remember, because I use it so much, I've got an acronym. And now, because CDA and EDG were used in the statement right above here, I can show what EDG equals, which is angle F, and what CDA equals, and that's angle B, and that's my last statement. And my reason is substitution. So because angle B was congruent to angle CDA and angle F was congruent to EDG, and I just shown that they were vertical, I can now use substitution and say angle B is congruent to angle F. Okay, I'm going to go ahead and add a picture of a graph in here because I'm going to graph these 3 ordered pairs. Okay, so let me go ahead and graph the 3 ordered pairs. That's going to be step 1. So step 1, first step, number 1, is going to be to graph the vertices W, X, and Z. Let me go ahead and graph those ordered pairs. So W is -1, -3. X is -3, +2. And Z is +4, -4. I'm going to go ahead and connect them. So what they want me to do is find the missing 4th vertice, which is vertex Y. Now, remember, by definition, a parallelogram has 2 pairs of parallel sides. So what I'm going to do is I'm going to find the slope of this side here, WX, and then from there, I'm going to move that rise and run. Now, if you have something like this that's already graphed, you can actually, and if it's on actual graph paper or a picture of a graph, you can count the rise and the run and move that same rise and run. But let me go ahead and just do the slope formula. So I need to find the slope of WX. And again, I could count the rise and the run, but I'm going to go ahead and do the slope formula. The Y2 minus Y1 over X2 minus X1, and I get 5 over -2. Now for step 3, I'm going to take the slope, and remember, slope is rise over run. I'm going to take the slope and I'm going to move the rise and the run to get, so I'm going to move the slope to get to y. So I'm going to rise up 5, and I'm going to run to the left 2 units, because that was my slope. And I'm going to move it from z. So if I count up, 1, 2, 3, 4, 5, and then run 1, 2, my ordered pair for y is right here, and it's the ordered pair 2, 1. So let me erase the blue. And if you connect the points now, this creates your parallelogram. Now, what we want to do for step 4 is we need to verify. So we need to verify that the slopes are equal. So the slope of wx and yz should be the same, and the slope of xy and wz should be the same. Now, I already did the slope for wx or xw. Remember, that was the 5/2. And then to get this point, I did move that slope. So those are equal slopes. So let me just confirm that xy and wz are the same. So my slope of xy is going to be 1 minus 2 to minus -3, -1/5. And then my slope of wz, -4 minus -3, 4 minus -1, gives me -1/5. My slopes are equal. So the slopes are the same. So I know that I've found the correct order pair. Now again, if you've graphed it nice and pretty, then you don't actually have to do the slope formula. So what you could have done is you could have also counted the rise and the run. So if you went for wz, if you went from z, notice it goes up 1, and then it goes over 5. This one the same, goes up 1 and over 5. So you can also count the rise and the run if that's easier for you to do. Either way. So that is it. The answer to this question was y is the ordered pair 2, 1. So if you've graphed it, you could also have guesstimated where it is, but you really should confirm it with the slope. Because if you're just one box off, because your slope is off, that's the wrong coordinate. So it's better to use your rise and run and find the exact coordinate.